recursive method or false position method. Also, what is we have seen how to represent geometrical representation of bisection method and regular false method. Now in today's lecture we are going to start iteration method. Okay, so suppose f of x is equal to 0, b a given function whose root you want to determine. You want to determine the value of x which satisfy f of x is equal to 0. Then next step is what? Transform your f of x is equal to 0 to x is equal to phi of x, where you have to select phi of x is that phi of x must satisfy mod of phi dash of x less than or equal to 1. Okay, once you identify your phi of x and suppose x0 be any any approximate root, in an interval I a b. Okay, how to select a and b? Already we have seen in previous two methods. The a and b are numbers that f of a and f of b is in opposite sign. Okay, f of a and f of b have opposite sign. Then you have to select any x0 which lie in this interval ab. Okay, then find the value of x1 which is equal to phi of x1, phi of x0, x2 is equal to phi of x1, x3 is equal to phi of x2, and so on. Okay, xn is equal to phi of xn minus 1. And when you have to stop this process, when you will get an desired root of accuracy. Okay, so now take an example. Find solution using the iteration method. Find solution using iteration method f of x is equal to x cube plus x square minus 1 plus x minus 1, x cube plus x minus 1. So now what is our step? First we want to identify an interval containing root of this equation. So how to determine an interval? Again it's very simple, just start from 0, f of 0, find the two successive opposite numbers. So f of 0 is what? Minus 1, 0 plus 0 minus 1. F of 1 is what? 1 plus 1 minus 1 is 1. So this is less than 0 and this is greater than 0, and therefore our root lie in an interval 0 to 1. In an interval 0 to 1. Now next step 2. In this method we have to write our function f of x, or we want to transform our So now you have to identify that how many ways we can write our function such that x is equal to phi of x. For example, we can write this function as x is equal to 1 minus x cube. This is one way. Okay. Another way is what? If we take x outside from the bracket, then x square plus 1 is equal to 1. So x is equal to 1 upon x square plus 1. Okay. There is one more method to write x is equal to phi of x. But if we take the derivative of here, what is the derivative of phi of x here? If we take, if this is the phi of x, then derivative what? Phi dash x is equal to minus phi x square. And if we take its mod, then you will get it is equal to phi x square, and it is not less than 1 in the interval 0 to 1. In this interval, your phi dash of x is not less than 1. For example, if you put x is equal to 1, then phi x square is what? 3, and it is greater than 1. So this is not our phi of x. Understood? I am going to explain again. Suppose we write our phi of x is equal to, suppose we write x is equal to 1 minus x cube. Then what is phi of x? If you compare x is equal to phi of x, then what is here phi of x? Phi of x is equal to 1 minus x cube. So if you take the derivative, it is what? Minus phi x square. And suppose if you take the mod of phi dash of x, it is equal to phi of x square. So we want to select phi of x such that the mod of phi dash of x must be less than or equal to 1 in the interval 0 to 1. So if you observe, if you take x is equal to 1 here, mod of phi dash of 1 is equal to 3, it is not less than 1. So this is not our phi of x. This is not phi of x. So again, if we take x outside, then here I am writing, if we take the x outside, then it is what? X square plus 1 is equal to 1. So x is equal to 1 upon x square plus 1. Okay, so if you compare x is equal to phi of x, then what is phi of x? Phi of x is equal to, this is what we have compared it at this step. Compare this equation with x is equal to phi of x, you will get phi of x is equal to 1 upon x square plus 1. Now we want to check whether this function, whether this phi of x satisfies the condition mod of phi of x is less than 1. So what is phi dash of x? Phi dash of x, we know that. What is 1 upon x square? It is what? Phi dash of x is equal to the derivative of x square is what? Twice x divided by x square plus 1 bracket square. X square plus 1 bracket square. And if you take its mod here, you will get it is what? Twice x divided by x square plus 1 bracket square. Now if we check the value at x is equal to 0, we will get 0. And if we take x is equal to 1, then 2 divided by 1 plus 1, that is 2 divided by 4, it is what? Less than 1. So this condition, this phi of x satisfies. This phi of x is what? It is less than 1 for x belongs to 0 to 1, and therefore what is phi of x? Phi of x is equal to 1 upon x square plus 1. So once you identify your phi of x, next step is what? Take any x0. Take any x0 in the interval 0 to 1 is an approximate root. Suppose we have selected here x0 is equal to 0.5. Then what is x1? x1 is equal to phi of x0. So x1 is equal to 1 upon 0.5 bracket square plus 1. So x1 is equal to 1 divided by 0.5 bracket square plus 1. So it is what 0.8. This is what x1. Now next x2 is equal to x2 is equal to phi of x1, and therefore x2 is equal to phi of 0.8. What is our phi of x? This is phi of x. So what is phi of x2 is equal to 1 divided by 0.8 bracket square plus 1. So to solve this you will get it is 0.610. Okay. So now next x3 is equal to phi of x2. So it is what phi of 0.610. It is equal to 1 divided by 0.610 bracket square plus 1. If you solve this, you will get x3 is equal to 0.729. Now next x4 is equal to phi of x3 729. So x4 is equal to 1 divided by 0.729 bracket square plus 1. So it is equal to 0.701. This is what x4. Now next, so we have selected x0, which is an approximate root lying in the interval 0 to 1. Next we find the x1 equal to phi of x0, then phi of then x2, we will now find the value of x3. Okay, x4. To observe the x3 and x4, they are correct up to 1 decimal places. But in question, or if it is not given, still you want to determine a root correct up to at least 3 decimal places. So if you observe the x3 and x4, they are correct up to 1 decimal places. Now next, if you find x5 is equal to what? x5 is equal to phi of x4 is equal to phi of 0.701, and if you find this value, you will get x4 is equal to again 1 divided by 0.701 bracket square plus 1. If you find this value, you will get 1 divided by 0.701 bracket square plus 1 is equal to again is what 0.701 is equal to 0.701. So now if you observe the x4 and x5, if you observe the x4 and x5, they are correct up to 3 decimal places. So what is your answer? Answer is what? 0.701. Now take one more example. Take one more example. Find and root of an equation twice x is equal to cos x plus 3. Find an equation, find the root of an equation twice x is equal to cos x plus 3. Okay, correct up to 3 decimal places. We want to determine the root of this equation by correct up to 3 decimal places. So now by using iteration method, so what is our first step? What is our f of x? F of x is equal to twice x minus cos x minus 3. So what is our first step? We want to determine an interval containing root. So f of 0 is what? 0 minus 1 minus 3. So it is equal to what? Minus 4. What is f of 1? F of 1 is 2 minus cos 1 minus 3. I think this is also less than 0. If you find this, you will get less than 0. If you find the f of 2 is what? 4 minus cos 1 minus 3. So if you find this value 4 minus, but do remember while evaluating the value of cos sine, your calculation must be in radian. Okay, so 4 minus cos 1 minus 3, it is what? 0.45 596. So it is greater than 0. So this is less than 0, this is greater than 0. So our root lie in the interval. Therefore, root belongs in the interval 1 to 2. 1 to 2. Now, once you identify your root containing an interval, our next step is what? We have to transform. We have to transform this equation in the form of x is equal to phi of x. So now if you observe, since given twice x is equal to cos x plus 3, I think there is only one way to write x is equal to cos x plus 3 divided by 2. Now whether it is our phi of x, how to identify? Suppose if you compare x is equal to phi of x, if you compare, you will get phi of x is equal to cos x plus 3 divided by 2. Okay. Now whether it is our phi of x or not, how to check? By evaluating the derivative. Okay. So find the phi dash of x. So phi dash of x is what? It is what? Minus sin x. Okay, minus sin x, and derivative of minus sin x divided by 2. Minus sin x divided by 2. This 1 by 2 outside, derivative of cos x is what? Sin x. And so therefore, if you take the mod of phi dash of x, then it is equal to sin x by 2. And it is what? We know that the sin x is always lie in the interval minus 1 to plus 1 for any real value of x. And therefore, it is less than 1 always. And that's why, therefore, what is of phi of x? Therefore, phi of x is equal to cos x plus 3 divided by 2. This is phi of x. Now, once you identify phi of x, next step is what? Next step number 3. Select any x0 lie in the interval 1 to. Select any x0. You can select 1.2, 1.3, 1.4, 1.5, 1.6. We are selecting here x0 is equal to 1.5. Then what is x1? x1 is equal to phi of x0 is equal to phi of 1.5 is equal to cos of 1.5 plus 3, okay, divided by 2. So it is equal to 1 point, x1 is equal to 1.5354. Okay, now next x2 is equal to phi of x1. So phi of 1.5354. So cos of 1.5354 plus 3 divided by 2. 1 point, x2 is equal to 1.5177. If you observe the x1 and x2, they are correct up to 1 decimal places. But in question, we want to determine root must be correct up to 3 decimal places. So now next, we have to determine the value of x3. x3 is equal to what? x3 is equal to phi of x2. So x3 is equal to phi of 1.5177. So cos of 1.5177 plus 3 divided by 2. 1.5265. So this is what x3. Now next, find the value of x4 is equal to phi of x3. So it is equal to x4 is equal to cos of 1.5265 plus 3 divided by 2, 1.5221. Now if you observe the x3 and x4, they are correct up to 2 decimal places. So now next, x5 is equal to phi of x4 is equal to phi of 1.5221. So x5 is equal to cos of 1.5221 plus 3 divided by 2 is what? 1.5243. Okay, next x6 is equal to phi of x5. So next, cos of 1.5243 plus 3 divided by 2, you will get 5232. This is what? x6. Now find x7. x7 is equal to what? Phi of x6. So x7 is equal to phi of 1.5232. If you find cos of 1.5232 plus 3 divided by 2, 1.52. Now x7 is equal to 1.5237. Now if you observe the x7 and x6, if you observe the x7 and x6, they are correct up to 3 decimal places. Here also 1.523 and 1.523. So what is our answer? Answer is equal to 1.523. So this is what? An iteration method. But when we are going to stop our process, when the successive previous 2 roots are correct up to 3 decimal places. So here if you observe x6 and x7, they are correct up to 3 decimal places. So what is the root of when this equation? Twice x is equal to cos x plus 3, it is equal to what? 1.523. Okay, if you put this value here in this equation, you will get your answer is not exact. It is not exactly 0, but it is very 0.000 and then something. And so it is very close to 0. So want to stop here for today.